පටන් ගන්න 9 board මම පස්සේ කියන්න.
I wish a very good morning to all of you. Join the parallel session 3 biological science theme. I'm Dr. Nayana Nilakaravasam, the theme convener for the biological science theme. You can see me as TC-Dr. Nayana in the participant list. Today, we have Taranga to give all technical support for playing presentations to keep smooth running of the session. As we have instructed, the participants must rename themselves with the paper ID underscore with the name for us to identify you easily. So now we are about to start our session, and I am privileged to introduce the session chair, Professor Tamara Veerasinghe, the professor in Department of Botany of the Faculty of Natural Science of OUSL. She's a well-known person in the university, being head of the Department of Botany and the Center for Environmental Science and Sustainable Development. In addition to the chair, we have a co-chair in this session, Ms. Sandali Pavitra from the Department of Botany, to take over the session. If there is any connectivity problem with the chairperson, once the chairperson returns, she will take over the session. Now, I invite Professor Tamara Veerasinghe, to take over the session.
Yeah, thank you very much, Dr. Nayana. Very good morning again to all of you, right? So, and also let me warmly welcome all the authors and participants to this online parallel session 3 biological sciences of ours 2021. So as you are already aware, since this is a virtual conference, the pre-recorded presentations will be played. So duration is, each presentation is 10 minutes approximately. And there will be a Q&A session after the presentation that will be nearly 5 minutes, right? And I would like to inform you that please keep all your microphones muted and videos switched off for the better hearing for the rest of the participants, right? And I hope you have already renamed especially the presenters, each paper with your paper ID, right? And during Q&A session, authors can unmute their mics and also including the presenter and can answer the relevant questions, right? And also please switch on the video at that time. Right? And let's go to the session, our parallel session. We have 5 presentations lined up for this session. So let me begin with the first presentation, right? First presentation is on invasion of Parthenium hysteroporus weed over other common weeds in the Vavuniya district, Sri Lanka. Authors are K. Arjunan, A. Nantakumaran, S. K. Yatigammana, and S. Devasi. K. Arjunan is the presenter. Over to you, Mr. Arjunan.
Hello everyone, this is Arjunan from Department of Bioscience, Faculty of Applied Science, University of Vavuniya. I am very much glad to present my research findings at Open University Research Sessions 2021. The title of my presentation is Invasion of Parthenium hysteroporus weed over other common weeds in the Vavuniya district, Sri Lanka. First of all, Under the introduction, Parthenium weed is an annual herb native to tropical and subtropical America. Parthenium is an aggressive invasive weed threatening natural and agro ecosystems in over 30 countries worldwide. There are few attributes of Parthenium which made it as more competitive in comparison to associated flora. Those are rapid germination of seeds, prolific seed production, seed persistence in soil seed banks, seedling growth, short or extended life cycles, and allelopathy capacity. There are different beliefs about the introduction of Parthenium in Sri Lanka. Currently, there are growing concerns about the control of Parthenium weed in agricultural and natural ecosystems. Based on this research problem, the objectives of our study are firstly to study the agroecological distribution of Parthenium weed, secondly to identify the main impacts that occurred on the distribution of associated native flora due to the invasion of Parthenium weed. Here I am showing the study area map, the Vavuniya district, into 2 kilometer grids, and the red color grids show the infested, Parthenium infested grids. We obtained this distribution information from the provincial profile mapping of invasive alien species by Ministry of Environment in 2016. Then under methodology, we conducted field survey in 21 villages selected from the distribution maps. We had 10 sampling quartets at each sampling village, in which 5 were infested quartets and 5 were non-infested quartets. We did the quartet survey over 5 different land use classes, namely cultivated area, uncultivated area, tanks and associated lands, roadside and settlements. We got the count of the number of individuals of each species in quartets, and using the counts we calculated absolute density, relative density, Shannon species richness index, and Shannon species evenness index. Next, I am moving to the result section. So here I am showing the absolute density and the relative density of Parthenium weed as well as the associated flora. Here you can see the absolute density and the relative density of Parthenium is greater than the absolute or relative density of associated flora in all the instances. Roughly, Parthenium had 3 or 4-fold time differences from the absolute and relative density of associated flora species. Next, I am moving to the Shannon Richness Index and Shannon Evenness Index. Over all the land use types, you can clearly see the infested quadrants showed lower Shannon richness as well as evenness index, which indicating the Parthenium infestation has impact on species diversity as well as the abundance. Noticeably, in tank associated lands and in uncultivated areas, we found the significant difference in the Shannon richness as well as evenness index of species. Which is indicating in those land use forms, Parthenium infestation has more impacts than the other land use types. But we are in a difficulty to come to a decision whether it's because of the invasion of Parthenium or it's because of the water availability or other kind of management practices. For example, in tanks and associated lands, the water availability is comparatively higher than the other land use types. Therefore, water availability may have some sort of interference. On the other side, in the uncultivated area, there are not much or intensive management practices over there. For example, no ploughing or no management operations or weeding operations in uncultivated area. That may also have resulted the significant impact of the Parthenium infestation on these richness and evenness indices. Next, I am moving to the discussions. The Parthenium infestation has characteristic influence on the distribution and abundance of associated flora species. Differences in the absolute density of associated flora show the impact with varying magnitude of Parthenium infestation on the abundance or distribution of those respective flora species. Differences in the relative density showed considerable difference, which indicated the growth suppression of Parthenium species vary among different plant species. Also, the Shannon diversity indices, that the considerable reduction in Shannon diversity indices showing the impact of Parthenium infestation on the species diversity and abundance in different land use types. Here are the references. Thank you. Any questions?
Yeah, thank you, Mr. Arjunan. It's a very good presentation and very clear presentation. So I invite the participants for any possible questions, any doubts to be cleared. It is discussion time. Mr. Arjunan, I have a small question, like you name these plots as land use systems, like land use types. So how would the kind of like the adjoining areas to the roads and then the round water tank, those things become like kind of land use? Are there any cultivations?
Yeah, actually the cultivated lands, in the sense, at the time of the survey, there were no crops. The lands were in use for cultivation because
Even the roadsides?
in the roadsides, we did the quadrant survey. You are asking about
Because when you name a particular plot as a land use, there should be a kind of typical cultivation or typical land use pattern, I think, because it is not a kind of land use pattern. It doesn't matter, but you have chosen just for comparison, right? That is fine, right? And the other thing is, I would like to just inquire about the Parthenium infestation. Now, you mentioned about the provincial map related to Vaunia or Samya done by Mahabali Authority.
yes.
Yeah, is there any difference that was done in 2016, as I remember? So is there any difference, increase of Parthenium infestation from that point up to 2020 or 19, in which year you conducted based on your results?
Yes, madam. Actually, the study was conducted, the survey was conducted in the mid of 2017. After that, I went for my PhD. This is my Master's of Science work.
Right, okay.
Now only I was able to
Yeah.
present these findings. But they have it's a kind of seasonal effect on the Parthenium invasion over there. And I want to specifically mention with the roadside distribution, there were differences because of the stagnation of water. In some places, roads on the top and the sides have a stagnant water during the rainfalls.
Yeah, that is true.
So,
Okay.
yeah.
Yeah, so I don't think that kind of like having water deficit, those things are common to, I think, other non-infested ones as well. So I think the main problem with the Parthenium is the kind of very reproductive, very high rate of reproduction and all that. Thank you very much, Mr. Arjun and team, for giving a very good insight into this very difficult problem in Sri Lanka right now. Thank you so much. Right. So let us move to the second presentation in the morning session, right? That is ID 23, preliminary investigation of wound healing potential of the leaves and bark of Sisyphus enoplea. Authors are WMP Samrasinghe, KH Jayawardena, C. Ranasinghe, S. Somaratna, GMKB Gunarera. The presenter is WMP Samrasinghe.
I am Priyantha Samarasinghe. Welcome you all for my presentation on preliminary investigation of wound healing potential of leaves and bark of Sisyphus enophila. I would like to start my presentation with a brief introduction. Plants and plant-based preparations are used for wound healing in traditional medicinal practices in Sri Lanka. Although there are many plants used for wound healing in traditional medicine, only very few have been scientifically evaluated for their efficacy. Sisyphus enophila in Sinhala, we call Hing Ereminia, belongs to the family Rhamnaceae, is a plant used in traditional medicine for the treatment of wounds. Traditionally, the leaves, bark and roots are the most used plant parts. In present study, we aim to evaluate the wound healing potential of leaves and bark of Sisyphus enophila using scratch wound assay with Merdine Darby canine kidney cells. Stem bark and leaves of Sisyphus enophila were collected from the Dompe area. Dried and powdered plant materials were extracted sequentially with hexane, dichloromethane, ethyl acetate and methanol. The solvents were removed, weighed. Each extract was subjected to scratch wound assay at a concentration of 20 mg per liter. Scratch wound assay experiment was carried out with MDCK cells. MDCK cells was cultured in 24 well plates. They grow as a monolayer. Once the monolayer is developed, a scratch was made along the vertical axis of each well and washed with PBS. Then the wells were treated with test samples. Width of wound at the beginning was measured and taken as the means of 5 readings. After that, the plates were incubated in a humidified incubator for 24 hours at 37 degrees Celsius with 5% carbon dioxide. After 24 hours, width of each wound was measured and taken as the means of 5 readings. The scratch wound assay experiment was carried out in triplicates with 2 negative and 2 positive controls. Cell migration enhancement was presented as the mean percentage wound closure. Mean comparisons were performed using ANOVA and LSD test with significant level of P less than or equal to 0.05 using SAS version 9. Here we can see the microscopic images of wound in monolayer cells at the beginning and after 24 hours of incubation. For example, width of wound treated with hexanes extract of leaves at the beginning is this, and after 24 hours of incubation, width is this. For negative control, width at the beginning is this, and after 24 hours of incubation, width is this. There is no significant reduction in width in negative control, but the significant enhancement of cell migration can be seen in hexane extract of leaves with compared to negative control. Here we can see the percentage wound closure for each extract obtained from Sisyphus Enophila. We have obtained 8 extracts. Of those 8 extracts, the enhanced wound closure was shown by hexanes extract of bark and hexanes dichloromethane and ethyl acetate extracts of leaves. Therefore, hexanes extract of leaves was selected for further investigation. Hexane extract of leaves has the wound healing activity was chromatographed over a silica gel column, and 6 major fractions were obtained. Each was subjected to scratch wound assay at a concentration of 10 milligram per liter. Here we can see that the fraction 3 has the highest activity. The fraction 3 was further fractionated using silica gel column, and 4 major fractions were obtained. Each was subjected to scratch wound assay at a concentration of 5 milligram per liter. The fraction 3C has the highest activity. This fraction contained a single compound and it was tentatively identified as lupiol by TLCs and co-TLCs. From this study, we can conclude that the hexanes extract of bark and the hexanes dichloromethane and ethyl acetate extract of leaves of Sisyphus Enophila exhibit wound healing potential. Bioassay guided fractionation led to the isolation of the wound healing active compounds from the hexanes extract of the leaves of Sisyphus Enophila. This compound has been tentatively identified as lupiol by comparing with authentic sample of lupiol on TLC. Therefore, this study partially provides scientific proof for the use of Sisyphus Enophila leaves in traditional medicine for treatments of wounds. Further investigation of these extracts to identify wound healing active compounds is underway. Finally, I wish to thank National Science Foundation for financial assistance, the staff, National Herbarium for their help in plant authentication, head and all staff of Department of Chemistry for providing facilities, Mr. Dharaniyagala, Department of Chemical Engineering, and laboratory staff of Chemistry Department for their technical support. Thank you all.
Chairperson, you are muted.
Yeah, thank you very much, Ms. Samarasinghe. Priyantha Samarasinghe, it's a very good piece of work, I must say, and it's clear, very, very clearly you presented the work you did. And you have done it systematically also because you have a very good team of experts with you. So the session is now open for relevant questions and questions. Please ask any questions from, if you have, from the team. It seems no questions because it's so clear. I think it's an ongoing project too. So I think it's premature for me to ask this question actually. Any idea of, or I know it's a long process, the commercialization, because which is the main problem in Sri Lanka right now, as per even Professor Halwatura, that we are not commercializing. You have any furthering? I know definitely you will be furthering. Any idea with the drug industry or something? Must be.
Mr. Chairman, can I answer that question?
Yeah, sure.
Well, drug development will take fairly long.
I
It's a
know.
long process.
Yeah.
So we are probably at the very start of the project.
Yeah.
So which we have to do. I mean, which we have to go over very long way, maybe
Very
about
long way, but
several
still,
years. But of course, yeah, we have some ideas. We have some ideas of production of various different skin grafts. So we'll see how it goes. As
yeah.
it goes, we'll see. Thank you very much for your question.
Yeah, can you advise us, like, if we use this, I know Sisyphus is being used by the traditional people. So now if we use these leaves, what is the kind of like best advisable way, like the crushed, or if you use in the traditional manner?
Normally we use fresh leaves
Yeah.
for fresh cuts.
Yeah, right. Fresh cuts without much crushing. Is that correct?
Yeah, just crushing and putting in on the wounds.
Right. Yeah, because, and it's just for my, I invite other questions too, because since there are no questions, I'm bound to. Yeah, sure.
I have a small question. Because you have used lupiol as one of the compound for your experiments, and finally you have found out that it is present in the plant you have used. So then is lupiol is already using for wound healing things?
Yeah, of course, already reported lupiol as the active compounds for wound healing. It has activity.
But it is not commercialized. You are not using it.
That's right. I don't think that is used as a drug, but we have already proven that lupiol is a fairly active compound, such as acetylglycoside, which is being used as a drug.
Actually, lupiol also some people they used for creams and all as an ingredient. So I have seen some papers.
I think there is a problem with the connection of the chairperson. It seems she has a power failure. I would like to invite Ms. Sandali Pavitra to take over the session. To invite the third paper to present.
Okay, madam. Yeah, until Professor Tamara returns, I will take in and the team for your nice presentation. Are there any more questions? Okay, if there are no questions, is motor. And that is zero.
I think she has a connection problem as well. So I will introduce the paper. It is the extraction and characterization of chitosan from the shells of mud clam, cockles, and freshwater mussels by Mr. R.R. Ahmed, R.G. Sanju, and BDM Mihiran. So I invite Mr. R.R. Ahmed to present the paper.
Hi everyone, I'm Emma Roshan Ahmed from University College of Anuradhapura, Department of Aquaculture and Aquatic Resource Management. My research topic is extraction and characterization of chitosan from the cells of mud clam, Gelaina coescens, Cockle gaffarinum, and freshwater mussels Laminidae species. Next slide. These are my content. Here I am giving brief intro regarding bivalve. It consists more than 7,000 species around the world, and it doesn't have the head and lack of radula, also one of the filter feeder organism. In bivalve, edible only muscle part cells are discarded. In seafood industry, cells considered as waste. According to that, bivalve produce offensive odor, encourage bacterial growth, and attract pests and pathogens. This is the history of chitin and chitosan. In the first, chitin extracted from the mushrooms by the Henry Barconnet. After that, chitin modified by Charles Roth, and finally named as chitosan by the Felix Hobbs Saylor in 1894. Chitin is a natural polysaccharide, and also its second abundant organic source can be extracted from cell wall of fungi and crustaceans. Chitosan is a linear nitrogenous polysaccharide, mainly isolated by treating crustacean cells, and also it's a biopolymer. Chitosan used in several fields. One of the ingredients can see in medical field, in water treatment processes, in industrial level, and food sites. This is my objective, to compare the chitosan yield and physiochemical and functional properties of extracted chitosan from marine bivalves, mud clam and cockle, and freshwater mussels. Following slides we will discuss materials and methods. To carry out my study, I was selected the two locations. One is Anuradhapura, Nuwara Laminidae species, and second one Kenya, Gelaina coescens, marine water 1, third one Calpitia, Gaffarinum, and it's also the marine water 1. Isolation procedure of chitosan. I collected the cells and washed and dried and grinded into powder forms, and I was added 10% hydrochlorine for demineralization and for deproteinization at 10% sodium hydroxide. Got the chitin, and to deacetylation used 40% sodium hydroxide and neutralized the samples. Finally got the chitosan product. These are some calculations used to analyze my product. Analysis of moisture used gravimetric analysis AOAC 1995 and used same calculation for AS, and for analysis of water binding capacity used no procedure. This is the main part in this research, to get the degree of deacetylation percentage. It reflects the balance between two kinds of monomeric residues. Here the calculation. We will talk results parts in the following slides. This is the overall view of results. Yield percentage is high in cockle when compared the other two species. Yield percentage of chitosan is high in cockle, about 36.08. In moisture results, mussel has high percentage at about 3.40%. In other two species, nearly same value. Ash content is high in cockle at about 52.40% because of remaining calcium carbonate and Cora's particle are there. Water binding capacity, mussels has high number, about 257.49, because when I am grinding, mussels has small amount hard pigment layer on the shells. Nitrogen percentage also high in cockle at about 48.96, and lowest value is 23.80 in mudclam. Slide shows spectrum photo of Fourier transformed infrared. The absorption band is between the 1070 and 1075 cm -1. Here can be see the degree of deacetylation percentage of each species. Mussels has the high number, about 24.97. Comparatively, all species above 20% chitosan product. This is the limitation of my study. Used high amount of chemicals to isolate. Therefore, the isolation cost is high. In conclusion part, bivalve is most suitable source to extract the chitosan, and species and preparation process can affect on physiochemical properties of chitosan. It's also eco-friendly one, can use small-hold businesses. To complete this study successfully, I would like to thank my supervisors and Jawaharlal University and my dear parents and friends. These are my references. Thank you for listening.
Yeah, thank you very much. Thank you very much, Mr. Ahmed. Yeah, it's open for discussion.
I am Kirtiri Javadana. Can I ask one question?
Sure.
Now, we have extracted chitosan from animals. Now, what sort of the extract you find as a cream or a powder or any paste?
Sorry, am I audible?
Yes.
Yeah.
Get,
Now
can
you
repeat the
yeah.
question?
Shall I repeat the question? Now you have extracted the chitosan from animals. Now, what sort of product you get as a paste or a powder or a cream? What is the final product you get?
I got the powder form transfer.
Powder form.
Yeah.
Okay. Have you any experience but using this chitosan for any medical purposes?
No, sir, I didn't. It's furthermore the medical field can use this product to their research. Furthermore, so I don't have the much more idea regarding the medical side the applications.
Okay, right. Thank you.
Yeah. Thank you. It's a good initiative and a good piece of work, Mr. Ahmed. And I also have a simple question like, can it use now, because since you have done water binding capacity, will it be able to be used for fertilizer as well? Is there literature says something like that?
And used a small amount, and we have to mix with the other particles also, ma'am. As we can use as the ingredients for the
Yeah.
fertilizer.
Okay. Thank you very much. Are there any more questions?
Yes, madam. I have small question. From,
Yeah, sure.
my question is now: did you check the purity of this cytosine from your sample? Because now normally it apply for the biological purpose.
Yeah.
So have you done any purity assay, something like?
Well, not a purity. When I'm doing the extraction, usually for a new neutralization, we strip the water, running water. Every usage of the chemicals, we clear through the normal water in neutralized for up to pH 7. So it could be a better thing. The purity I didn't check. So furthermore, we will discuss in the future researches.
And also about physical properties of your product.
Yes, sir. It means the cocal has some sort of like a small, tiny, not a tiny, higher than the tiny, and other two muscles and gelino has the very tiny powder form. I received using a 400 micrometer mesh size.
Okay. Thank you very much.
Yeah, thank you, Mr. Ahmed, and the team for a wonderful job you have done. It's a very way forward for a better binding, right? Thank you once again, right? So let me go to the next presentation. That is ID 154, glycemic, lipidemic, and immunomodulatory effects of fenugreek, Trigonella phenum, seed consumption on male albino visca rats. Authors are P.S. Samarakon, C.D. Jayasinghe, U.A. Jayawardena, and Neela Karyavasam. The presenter will be Ms. P.S. Samarakon.
Greetings to all of you. Our research topic will be glycemic, lipidemic, and immunomodulatory effects of fenugreek seed consumption on male albino vista rats. I am Pumi Samarakon. These are the contents I have in lineup for you. In the 21st century, of course, if you leave aside the current pandemic, NCDs have become the silent cause of the rising mortality worldwide. In Sri Lanka, out of a research done by the WHO in 2018, in 2016, out of the total population of 20.8 million and total deaths of 143,000, NCDs are estimated to account for 83% of all deaths. NCDs are mainly caused due to behavioral misconducts of people. It can be smoking, harmful alcohol use, physical inactivity, and unhealthy diet. These behavioral misconducts usually causes the occurrence of high blood pressure, hyperlipidemia, hyperglycemia, and obesity, and in turn, these conditions lead to the occurrence of fatal non-communicable diseases. And the crucial story is most of these NCDs are usually uncurable and can only be controlled. For example, diabetes mellitus is the inability of the body to regulate glucose levels, and raised serum cholesterol levels are usually associated with a number of cardiovascular diseases. Especially in developing countries like Sri Lanka, treatment of these NCDs are usually very expensive, and resources are low and the people cannot afford treatments. So the use of medicinal plants and bioactive constituents have become famous worldwide. Many medicinal plants have been screened and gained recognition, but yet many remain to be scientifically investigated. Fenugreek is such a plant. It is known as uluhal in Sri Lanka. The high nutritive value makes us use them as a flavoring, as a spice and seasoning in the preparation of our food. So for this study, I will mainly focus on the use of fenugreek seeds for the treatment of NCDs. The primary objective of my research was to investigate the glycemic, lipidemic, and immunomodulatory effects of fenugreek seed consumption on male albino vista rats. The specific objectives were to investigate the intensity of phytochemicals in fenugreek qualitatively in different extraction media, determine the effect of fenugreek on blood glucose level and cholesterol levels using an in vivo model. Third was to investigate the potential toxic effects of the consumption of fenugreek and to also determine the immunomodulatory effects of fenugreek seed consumption. This is the methodology I adapted. For the phytochemical analysis, I prepared 5 different extracts and testing was done qualitatively. These were the extracts. For extract 1, I used 5 grams of raw seed soaked in 10 ml of distilled water and kept overnight. And for extract 2, 3, 4 and 5, I used a shaker and each solution was kept in the shaker for 48 hours. For extract 2, I used 5 grams of raw seed soaked in 10 ml of distilled water. For extract 3, I used fenugreek powder soaked in 10 ml of distilled water. And extract 4, I used 5 grams of fenugreek powder soaked in 10 ml of ethanol. Extract 5, I used 5 grams of fenugreek powder in 10 ml of methanol. So as we used male vista rats as the in vivo model, ethical approval was granted from the Institute of Biology, Sri Lanka. This is how we prepared the fenugreek drug for the treatment. So first we obtained fenugreek seeds available in the local market and we washed seeds, cleaned and sun-dried them to remove any extraneous material. The raw seeds were used after that, and to obtain a powder we used a mixer grinder and grinded the fenugreek seeds to obtain a fine powder. Before the beginning of the experiment, we purchased 24 male rats of Vista strain from the MRI Medical Research Institute Boralla, and then we acclimatized them to standard laboratory conditions for 1 week before the commencement of the experiment. We had 4 groups according to the treatment they will receive, so they were abbreviated as follows. The SS group were the rats that received the seed soaked in water overnight, and the PS group were the rats that received the powder of fenugreek. PC was the positive control and NC was the negative control. So as part of the initial treatment, excluding the negative control group, all the other groups received a mixture of egg yolk and cheese of 1% body weight during the period of the study to have measurable levels of cholesterol and glucose in their blood serum. After a 2-week induction period, bleeding was done by tail vein Nican anesthesia, and serum was collected and total cholesterol levels and glucose levels were measured initially, and using anticoagulated blood, differential WBC count were identified and lymphocyte and neutrophil ratio was calculated. So for this study, they received 270 milligrams of seed soaked in water, soaked in 3 ml of water, and the powdered group, they received 270 milligrams of fenugreek powder. So this is a summary of how they received their treatments during the entire period of study. So these are the 4 groups and they all received their water and normal diet throughout the period of the study, and they received the cholesterol treatment excluding the negative control. All of them received the cholesterol treatment, and fenugreek treatments, as I stated before, they were given to SS and PS groups. After 28 days of successful treatment, bleeding was done by heart puncture method and about 3 cc amount of blood was collected. Later it was centrifuged to obtain serum. So first blood was collected and Giemsa staining was done to prepare the smears, and the rest of the blood was centrifuged to obtain serum samples. So the assays were conducted to analyze the final glucose levels, total cholesterol levels, triglyceride, to analyze toxicity parameters, and using standard methodology we conducted the assays according to the protocols of the assay kits. So here we can see the ELISA microplate prepared for serum glucose test and the microplate prepared for total cholesterol test. To analyze the non-functional immunological parameters using non-coagulated blood, we found out the total WBC counts, differential WBC counts, red blood cell counts, and the platelet counts using a hemocytometer. So now I will move into the most important part of my research, the results section. Out of the phytochemical analysis done, we found out that extracts 1 and 2 the tested fenugreek treatment methods, had the highest number of phytochemicals that we tested qualitatively. The plus sign indicates the presence and the dash indicates the absence. At the final bleed, the total cholesterol levels in the seed soaked in water group showed a significant reduction when compared with the positive control and the negative control, and also the powdered seeds form. They also have a reduced level of total cholesterol at the end of the treatment period, suggesting that it was effective in our case. At the final bleed, the glucose levels in SS and PS group showed a significant reduction when compared with the two control groups. These are the other parameters and their levels and concentrations at the final bleed after the administration of fenugreek treatment after 28 days. If we look at literature, studies focus in analyzing the presence of phytochemicals in seed soaked in water method was scarce. So we can say that the extract 1 contained a lot of important phytochemicals, and also it contained tannins and saponins. And studies have reported that saponins was the cholesterol lowering agent present in fenugreek. So we can say this extract 1 was effective in reducing the cholesterol levels, and it can be used for further testing. The results revealed a significant potency of SS, the traditional method of treatment, on reducing both the glucose and cholesterol levels of the treated rat groups. And the powdered seed method that was used was effective, but it was comparatively lower than that of the SS group. So we can suggest that the traditional method of consumption of fenugreek in Sri Lanka was effective in treating hyperglycemia and hyperlipidemia. Since overall observations did not show signs of toxicity, we can say that fenugreek is safe as a drug in the drug development research, and a lot of research and other studies can be based on this study. So in conclusion, I would like to say that the traditional method that was tested was effective, and it has a significant potency in lowering the glucose and cholesterol levels in blood. Therefore, it can be used as a cheaper alternative. These are the references I used. Finally, I would like to thank all those who supported me in numerous ways, and especially Dr. Naina, Dr. Utpala, and Dr. Shanika for guiding me and supporting me from day one. Thank you.
Thank you, Pumi. Again, I must say it's a good piece of work, and you very well presented as well, and you are aware what you are doing and all that. So now it's open for questions now. Audience can question now.
Can I ask a question? I am Kit Trijawardena.
Sure.
Yes, sir.
Yeah, now I can see 3 supervisors from the SU department. I am also from the SU department. You could have asked question previously, but it's a presentation. I want to ask a question now. Basically, you had the period of acclimatization of animal in the lab.
Yes,
one question is, did you check the cholesterol after the acclimatization? What was the level? I mean, if they have cholesterol, there should be a level. Then you have noticed that it has increased due to feeding, and certain animals that have decreased. My question is whether you have checked it after acclimatization, and what was the level? And the second question
yes,
is, did you starve these animals before feeding, or how do you feed them? Usually rats are eating and feeding all the time. So how did you manage to feed them?
Yes, sir. For the first question, we had an acclimatization period of 1 week. So after the acclimatization period, we did the pre-bleed to check their cholesterol levels. That means we had to elevate their cholesterol levels to make them hyperlipidemic, because these rats were healthy rats. So then we had to make them hyperlipidemic in order to test for the levels. And the second question, we had to, so what was the question?
Feeding animal regularly, or a specific period, or whether you have undergone them for starving for a certain period?
Yeah, now it's clear. Now when we were giving them the cholesterol treatment, I made sure that one rat was in one, I transferred them separately into a cage one by one, and they were given the cholesterol treatment. And when referring to the fenugreek treatment, we used a Sonji needle, and then each of them were given the drug treatment after measuring their dose and body weight.
Okay.
Okay.
Any more questions from the team? I also feel, just to give you some idea, I think that because your results indicates that the powder form is less effective than the soaked form, right? So traditionally also when we use the fenugreek, most people, they use the soaked fenugreek. So I think the most active components are coming out during the soaking, I think. So that could be also one reason why you have got the more effective value for the soaked ones than the powdered one. Yeah. Okay. Thank you very much, Ms. Pumi and the team. So go ahead with your work. It's a good work, right? So let's move to the last presentation in the morning session, the first session, right? The last one is ID 64, a comparative study on some physicochemical properties of fresh and in-used oil used by street food vendors in the Vijayarama area, Gangodawila, Nugegoda in Sri Lanka. Authors are U. Diniti and P. Abesundara. The presenter will be U. Diniti. Over to you.
Good morning, everyone. My presentation is on a comparative study on some physiochemical properties of fresh and in-used oil used by street food vendors in the Vijayarama area, Gangodawila, Nugegoda in Sri Lanka. Street fried food vending is a growing phenomenon in developing countries like Sri Lanka due to their low prices and convenience. However, the repeated use of frying oil can produce constituents that not only compromise the quality of fried food but also have adverse effect on human health. The safety of fried food is directly associated with the quality of frying oil. Various malpractices followed by some street food vendors during food processing, such as mixing used oil with fresh oil and the improper storage of fresh oil and replenishment of oil during the frying process, have made the safety of fried street food questionable. In this study, the quality of fresh and in-use frying oil used by some street food vendors in the Vijayarama area, Gangodawila, Nugegoda in Sri Lanka was determined by using selected physiochemical properties such as acid value, iodine value, peroxide value, moisture level and insoluble impurity level. The main objective in this study is to assess the quality of fresh and in-use frying oil used by street food vendors in the Vijayarama area, Gangodawila, Nugegoda in Sri Lanka. Under specific objectives, to determine the quality of fresh frying oil, to determine the quality of in-use frying oil used by the selected street food vendors in the study area, and to compare the compliances and non-compliances obtained data with the standard specifications such as SLS and Codex. Let's move on to the methodology part. Under sample collection, 24 oil samples were collected from 12 street food vendors after about 3 hours of frying. 12 fresh oil samples obtained from oil stored in cans and 12 in-used oil samples obtained from frying pans. Then, a face-to-face interview was carried out to obtain information about the frying oil and frying practices. Under chemical analysis, determination of peroxide value, acid value and iodine value was done using AOCES standard methods. Determination of moisture level was done using AOAC standard method, and determination of insoluble impurity level was done using ISO standard method. And determination of trans fatty acid using GCMS method described by Chandran et al. With slight modification. Under statistical analysis, all experiments were performed in triplicates with a completely randomized design structure. One-way ANOVA test with two honestly significant different tests was carried out to compare the values calculated for the fresh or in-used oil samples of the 12 vendors. The paired sample t-test was carried out to compare the calculated mean value of fresh and in-used oil samples. Let's move on to the results and discussion part. All 12 vendors were found to be using palm oil for frying. However, information on the number of frying cycles of the collected oil samples were not considered in this study as street food vendors failed to provide accurate details. Then, the ideal value of fresh and in-used oil used by street food vendors. The ideal value is directly proportional to the number of mono and polyunsaturated bonds present in oil. Frying leads to decrease in unsaturation. According to the results obtained, only one fresh oil sample was found to be comply with SLS standard specification, that is 50 to 54 range. As we all know, all fresh oil samples should be complied with standards. But out of 12, 11 samples don't comply with that value. It indicates those oil are already degraded and it may be caused by various malpractices followed by street food vendors, such as prolonged exposure of oil to sunlight, heat or air due to inappropriate method of storage, or the oils were adulterated with used oil. You can see the values of all in-use samples were below the corresponding fresh oil samples, and results indicate all in-use samples are highly degraded. Let's move on to the acid value. Acid value indicates the level of free fatty acid present in the oil. According to the SLS standards, the maximum allowable level for acid value is 0.6 mg KOH per gram. You can see 5 fresh oil samples were found to be non-comply with SLS standard. This may be due to malpractices followed by street food vendors, such as mixing fresh oil with used oil or contamination of fresh oil with moisture during storage. All in-use samples were recorded a higher acid value. Let's move on to the peroxide value of fresh and in-used oil used by street food vendors. The higher peroxide value indicated accelerated primary oxidation in frying oil. According to the graph, all fresh oil samples were accordance with the standard specification, but all in-use samples were beyond the specification level, which is 10 milliequivalent per kilogram. The highest value was recorded by vendor L. The next one is the moisture level. Low moisture level is a requirement for longer shelf life, and higher moisture level leads to the hydrolysis of oil. All fresh oil samples were found to be beyond the maximum allowable level, that is 0.1%. It may be due to malpractices followed by some street food vendors, such as improper fresh oil storage and mixing leftover oils with fresh oils. All in-use samples recorded a higher moisture levels, and the second highest moisture level in in-use samples was recorded from vendor I, and it was the sample that recorded the highest acid value. According to the Codex standards, maximum allowable insoluble impurity level is 0.05%, but the standard deviation for mean insoluble impurities was greater than 100%. Therefore, it was not compared with the Codex standards. This graph illustrates the mean values of physiochemical properties of fresh and in-used oil samples after rejecting all outliers. Among the tested parameters, only the mean peroxide value of fresh oil samples was in accordance with SLS or Codex standards, and the mean iodine value was below the maximum allowable limit, and mean acid value and moisture level were above the maximum allowable level. And all in-use samples were highly degraded compared to the fresh oil samples. According to the conclusion, this study's data show that frying oil used by some street food vendors in the Vijayarama area, Gangodawila, Nugegoda, Sri Lanka, do not comply with the SLS or Codex standards. These non-compliances may be due to malpractices followed by street food vendors during food processing, such as mixing used oil with fresh oil, improper oil storage, and inadequate filtering or replenishment of oil during frying. The data revealed that compared to the fresh oil samples, all in-use oil samples were highly degraded with respect to the tested parameters. Under suggestions and recommendations, impose strict rules and regulations and increase awareness in street food vendors to preserve the quality of fresh oil and in-use oil samples, and to minimize the malpractices during food processing and promote good food processing in street food vending. These are the some of references that I used in this study. So I'm going to conclude my presentation here. Thank you very much.
Yeah, thank you very much, Ms. Diniti and Abhisundara. Right, it's a very good piece of work again, and on a very important aspect prevailing in the society. And we all are worried about having good oil for frying and at various levels. And especially we are very much worried about our children being used this food during their movie. So it's open for questions now. Any questions from the audience participants, please? I have a small question. Where did you do this analysis? Is it at the USJP or at the ITI?
At USJP, Madam.
Yeah, so you have these facilities in the food technology department, I suppose?
Yeah, Madam.
Yeah, and it's a very good, I think, as you have already said that you want to increase the sample size. I think you should do like it. It's prevailing in all around the country, especially in the city area. Nugegoda, Vijayarama is very famous because of the university. So you can extend a larger study and still worthwhile. But when I look at your recommendation, I also theoretically agree with those. But it's the difficult thing is I don't know how to monitor these things. Like either we should inform these findings with a larger sample after doing all this to relevant authorities to do at least random checking on these things or something like that through the PHI. So I don't know through whom, like otherwise it will be a real nuisance to the country. I think it's something we have to be very mindful as academics and later on with the administrators. Okay, thank you very much, Ms. Diniti and the team. It's a wonderful work, right? Thank you again. That is the end of the first session, right? We'll meet at 11:15 for the next session. Thank you. Thank you, the team, technical team.
Thank you.